And welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem number 76, minimum window substring. Before we get into the question prompt, I just want to kindly ask you guys to subscribe. It really helps the channel grow, so please go ahead and do that. Given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique, and a substring is a contiguous sequence of characters within the string. So let's look at this example where we have this string which is A, D, O, B, E, C, O, D, E, B, A, and C, and we're asked to find the shortest substring which contains A, B, C. So we're told that the answer is bank, but let's see how they got that. So we need our substring to contain A, B, C. So let's see if we can't create one from the beginning, because we see we have an A here and there's a B here. So one potential substring could be this, A, D, O, B, E, C, right? It contains all the characters we need, and this is length 6. But let's see if we can do any better. Well, are there any other A's in this? So we could do B, E, we could start at this B and go to this A. So this would be B, E, C, O, D, E, B, A. So this contains all of our characters, but this is of length what? 1, 2, 3, 4, 5, 6, 7, 8. So that is not a good solution because it's actually longer than a potential solution we found so far. But we can see that actually if we just grab bank, then we can do it in 4 characters, which is actually the best solution here, and we can get rid of this one. So essentially that's what we want to do, is we want to try to basically increase our sliding window until we have all of the characters. But obviously we may have gotten too many, right? If we start from the beginning, let's wipe everything out. If we think about the base case here, obviously the entire string has the characters that we need, or it could actually not have them, but let's just assume that it does, right? The entire string is gonna have A, B, C in it, but obviously that's too many characters. So whenever we verified that our characters are actually in our substring here, we want to start cutting down our window in an attempt to actually get that optimal shortest solution. So what we want to do is quite simple. First of all, we need to keep track of the exact counts of each character that we must have in our substring. So what we're going to do is we're going to have, let me, if I can just pull my pen up here, we're going to have a tcounts dictionary, which is going to basically keep track of the count of each of the characters that we need. So we have an A here, and it must have a count of 1, at least 1, right, in our substring. For B, we have the same, and for C, we also want a count of 1. Okay, now what we're going to want to do is we're going to want to keep track of the characters in our current substring, right? So we're going to call this, substring dict. And what this is going to do is it's going to keep track of the current characters in our substring that we have, right? So in our original example, if we had this substring, there would be 1A, there would be a D in here, there would be there'd be 1D, there would be an O, there'd be one of those, there should be a 1 here, there would be a B here, and there would be a C and also an E, right? So this dictionary is just going to keep track of the current characters that we have in our substring dictionary. So we're going to need one of those to keep track of whether or not our substring dictionary actually has the counts that we need for our tcounts here. And what we're also going to need to do is basically keep track of the points when our count in the substring dict actually matches that of what we need in the tcounts, right? It's okay if the count in substring dictionary is actually greater than tcounts, that's fine. We don't really care about that as long as it has the minimum required. So we're going to need to keep track of how many actual matches there are. So we'll call that required. And this required variable is basically going to keep track of the number of characters whose counts in substring dictionary is at least as big as the count required here. And when this count actually equals to the length of our t counts, then we will have said to actually have found all of our, our substring is now fine. The first point where we now have the required counts in our substring dictionary such that they match the required counts in t counts, we can actually stop our substring and now try to remove characters in an attempt to make it actually work. So let's go through an example here because it's a little bit confusing. So we still have our substring dictionary and it's going to basically be empty at first. And remember that we need to basically have a required count of 3, right? Because there's 3 items in our t counts. So once we have 3 items which are at their desired count, then we can say that this string is done. So what we're going to do is we're going to have a left and a right pointer in our array, and they're both going to start here at the 0th index. And what we're going to do is we're going to move the window larger by moving the right pointer until we are at the end of the string. And we're going to parse the current character, which is going to be an A. And we're going to add that to our current substring here. So we're going to say that we have now seen one A character. Now what we want to do is we want to check, okay, is this character A also in t counts? Yes, it is. And does our count in our substring dictionary actually equal the count in t counts? It does. So in this case, we're going to keep track of the amount of matches we have in a separate variable. So we're going to say matches is going to be 0. But now that we have one match in the characters, and remember a match is when the characters are in both dictionaries and the actual count here is the same as the count in t counts, then we can increment our matches. Great. So now we've gotten a match. And now what we want to do is obviously we've taken a substring of length A. And what we want to do is we want to check whether or not we can actually decrease our substring in the case that it's actually too big. And the only time we can do this is actually if we've formed a valid substring. Obviously, we don't want to start cutting things down before we actually match all of the characters, because there's no point. We could actually miss some solutions. So there's nothing for us to do. So we simply move on to the next character. So we move on to the D and we increment its count here and it becomes 1. Okay, is it in t counts? No, so nothing for us to do except move on to the next character, which is this O. So let's increment the count of O, or just add it to the dictionary. And since it's not in t counts, there's nothing for us to do. Then we get to the B, and B's count get added as 1. And now, because we have a B in our substring dictionary, which is also in our t counts and the counts match, then we can say that we have another match here. So we'll have two matches here. And since we haven't matched all the characters yet, we can't try to make our substring any smaller. So we're just going to continue. So we move on to this E here. And obviously E gets added to our count for the substring. And its count is now 1. And because there's no E in t counts, then we just continue. So then we get to the C here. The C count becomes 1. And now, because the C's match on the counts, we can now say we have 3 matches. So now, because the matches equals the number of required, we can see that this substring is actually a valid one, right? This was one of the original solutions that we came up with, and then it satisfies our minimum window substring, right? Or sorry, it's a substring, but it's not the minimum because its length is 6. So what we want to do now is we have the substring A, D, O, B, E, C. And we know that this substring works, right? Because it has the exact counts for A, B, and C that we want. But we want to see if actually we took too many characters here. So what we're going to do is remember our right pointer is at this C because we moved the right pointer up each time. But our left pointer remained here at this A. Now what we're going to do is we're going to move the left pointer up and see what happens. And we're going to pretend like we chopped off this A. So we move the left pointer up and we chop out the A, which means that A's count is now 0. And now because A's count is 0, it no longer is a valid substring because remember, we need at least one A in our substring. So therefore, doing that actually was not good. So we can't really improve on this solution because chopping the A would mean that we lose it being a valid substring. So that means that we can't do anything to reduce this substring. So now the left pointer is going to be at the L and the right pointer is at the C, and so we continue. So now what we want to do is we want to go to our O and we're going to increment the count here. And now what we want to do is essentially continue. So we go on to the D, and now the D's count will get incremented. Again, remember, since none of these characters are in T counts, we can't really do anything until we get another A. So now we get to this E here. So E's count gets incremented by 1. Again, we can't do anything. We get to the B, we can increment B's count, but we've already satisfied the fact that B is at least 1, so we don't increment our matches here. And remember, our matches are now 2 because we got rid of the A. So now we get to our A again, and now we can see that, okay, now A's count becomes 1 again. Now we have 3 matches. So now we have a new substring, right? This D up until A. So, right, we have this substring D, O, B, E, C, O, D, E, B, A. Okay, so we have this substring, and remember that our left pointer is here at the D, and our right pointer is here at the at the A. Apologies. So now what we want to do is remember that we want to start cutting things from the left in case we actually took too many characters. So let's see what happens if we chop this D. So the D gets chopped by 1, and now it has a count of 1. And we still have 3 matches because obviously D was not in T counts, so getting rid of it is not a big deal. So we were actually able to improve our solution, and we're going to keep doing this until we no longer have a valid solution here. So we can get rid of this O by moving the left pointer up to the B. So now we can get rid of one of the O's, and again, since O is not in T counts, no problem there. Now we can do the same thing with the E. We can reduce one of the E's, no problem. And then what we can do is we now get to the C. So obviously, if we get rid of C, then the count becomes 0, and this no longer becomes valid. So now we'll only have 2 matches. So that means that this is as far as we can chop, right? We can only chop this down to C, O, D, E, B, A, right? But that's still only 6. Which was, the same as our original solution, so we haven't actually found anything better. Now we can continue. So let's look at where our left pointer is. So our left pointer ended up at this C, so we can't move it up any further. And our right pointer is now at this R. So what we can do is we can actually go to, so we were not able to chop this C. So we did chop the C, and now we have to continue. So the left pointer is actually going to be at the O, and our right pointer is going to still be here at the A, and then we need to move it up because we just took the A in the last iteration. So now the right pointer is at the N, so let's add an N to our dictionary, and its count is now 1. Now what we want to do is we want to, again, check whether or not we have matches, but we don't because we only have 2. Remember, we got rid of the C. So now we go our right pointer to the C, and we finally have our C back. So now what we can do is we have 3 matches. Now we can start chopping things. So let's see what our string is, and it's getting a little bit messy here, but luckily we're almost done. So our string is looking like O, D, E, B, A, N, C, right? So let's now start chopping things. Can we chop this O? Yes, we can, because who cares about the O? So now O's count is 0. Can we chop this D? Yes, we can. So now D's count becomes 0. Can we chop the E? Yep, we don't care about it. E's count becomes 0. And now we've now found a new best solution, and now it has a length of 4. So when we try to chop the B, we'll obviously see that chopping it will, reduce its count to basically, 0 in our substring. So at this point, we would lose our last match, so we can no longer stop chopping. So our best solution that we found was that substring bank of length 4. So that seems like it's quite messy. It's a little bit confusing. It's actually a lot simpler when you look at it in code. So what I want to do now is transition to the code editor, because hopefully I haven't confused you guys too much and you've clicked off the video. But this is the general gist and the general walkthrough of how it works. I think it's useful to kind of see this because, for some solutions, it's a little bit less intuitive. This one, it's nice to kind of have it walked out. But what we're going to do now is we're going to go to the code editor. We're going to walk through this line by line, and it's going to be super clear, a lot clearer than actually drawing it out, even though this is like doing it line by line. So enough talking, let's go to the code editor and actually type this up. Okay, welcome back to the code editor. It's time to type this up. And I realized that the explanation part of this video was like 16 minutes long. So I'm going to try to get through this as quickly as possible because this video is going to be too long. Anyway, we want to check that our input is actually valid before we try to do anything. So obviously we need, our string S to be defined and our string T to be defined. And we actually need the length of T to be greater than the length of S, right? Because if you think about it, we want to find a substring of S that contains all the characters of T. But if T is actually longer than S, then that's not possible. So, because we actually need to account for the fact that duplicates are allowed. So, the length of T needs to be less than S. So, let's handle those edge cases. So, we're going to say if not S or not T, or the length of T is actually greater than the length of S, then what we want to do is just return the empty string because there's no solution here. Now, remember that we want to get the counts of all of the characters in T. So we're going to say T counts is going to equal to, and I'm going to use collections.counter here because I'm in Python and it's some nice syntactic sugar, but you can basically just loop through T and, increment the counts in the dictionary. This just does it for me. So now what I want to do is I need to keep track of my left and my right pointer. So I'm going to say left equals right. And remember, I need to keep track of the number of matches I have in my, substring to the counts in T counts. So I'm going to say matches equals to 0. So initializing those variables. Now I need to actually figure out how many matches I need. So I'm going to say required matches is going to be equal to the length of T counts, which is the number of times I need to correctly match the character counts in my substring to that count in T count for the character in question. Now, remember that I need a dictionary to keep track of my substring counts. So I'm going to say window counts, which is going to keep track of all of the counts in my sliding window. So this is going to be collections dot default dict int. So this is just going to save me from actually checking whether or not a character exists. I can just add it in there, and if it doesn't, it's going to get initialized to 0 as its count. So I also need to keep track of my solution here, because remember, we're not returning the length of the minimum window substring. We're actually returning the minimum window substring itself. So when I do find a solution, I need to basically keep track of its length, and I also need to know where it started and where it ended, because at the end I need to slice my string in that fashion. So I'm going to say my answer, and it's going to be a little bit of a complex answer. I'm going to use a tuple here, and the first item in the tuple is basically going to be the length of my substring here, and I'm going to initialize it to infinity, and I'm going to set the left pointer and the right pointer to be 0, because obviously we haven't found a solution yet. So now what I want to do is I want to increase the size of my substring, and I'm going to do that by moving the right pointer forward. So while right is less than the length of our string here, I'm going to say that the current character is going to be S of R. And now what I want to do is I want to say window counts of our current character is going to get incremented by 1. Obviously, we're adding it to our window dictionary and keeping track of its count. Now I need to check whether or not this character is actually in t counts and whether or not the counts are matching. So I'm going to say if curchar is in t counts and t counts of this current character actually equals the counts in window counts, window counts of the current char. If those are equal, then what I want to do is I want to say that we have a match here. So I'm going to say matches plus equals to 1. And now what I want to do is remember that every time we add a character, we actually need to check whether or not our substring is too big, but only if we have the right amount of characters. So we want to say while left is less than or equal to right, because remember we moved that left pointer up when we're trying to chop characters, and while matches equals to required matches, because remember we can't chop characters until our substring is actually fully formed. Otherwise we might be getting rid of characters that we shouldn't be getting rid of. So the only time we're actually allowed to chop characters is actually when our substring is fully formed. And remember, that is when our matches actually equals the number of required matches. So if this is true, then we can start moving our left pointer up and trying to chop things off. So we're going to say the character to remove is going to be whatever is at the left pointer index. And what we're going to do is, because matches equals required matches, if we're inside here, that means that we have a valid substring, right? Because matches equals the required matches. So that means that this solution is a potential solution. So we need to actually check against our best solution here in ends to see whether or not we've done any better. So we're going to say if left if right minus left plus 1, which indicates the length of our current substring, is actually smaller than ands of 0, and remember that ands of 0 represents the length of our best solution, then we found a new best solution, so we need to update our answer. So we're going to say the answer is now going to be right minus left plus 1, because that's the length of our new best solution, and it starts at index left and ends at index right. Cool. Now that we've updated our solution, we can now decrement the window counts of whatever to remove is. And now what we want to do is we want to check whether removing that character actually got rid of a match here. So we're going to basically do the same check we did here, and this time instead of incrementing matches, we're going to decrement it if it's true. So we're going to say if to remove was actually in t counts and the window counts of to remove is actually now less than t counts of to remove, then we've now lost a match, right? Because it's fine if we remove a character, but its count is still greater than or equal to t counts, the same character there. But as soon as that count is lower than t counts' count for that character, then we know that we've broken our logic and we now lost a match. So we need to say matches minus equals to 1. So now what we want to do is remember that this is a while loop and we're moving the left pointer up. So the last thing we want to do is actually just move the left pointer up by 1, and we are done there. So this while loop will either break when left is no longer less than or equal to right, or the matches are no longer equaling the required matches, in which case we break out of the loop and now we can continue moving our right pointer up. So the last thing we want to do is actually just increment our right pointer. So as you saw, this is going to go through the entirety of our string here. And at the end, remember that we have to return a string. So let's double check that we actually have a solution here. If our answer is actually still float infinity, then that means that we weren't able to actually find anything within our while loop. So we just want to return the empty string. Otherwise, we want to return the actual answer that we found. So we're going to say return, and what we want to do is if we have a solution, then we need to return it. And remember that our solution answer here stores the left and the right pointer to where our best substring actually starts and ends. So we need to actually chop the original string. So we're going to say return s from ands of 1, and remember that ands of 1 represents the left pointer or the start of our best solution, all the way up to ands of 2, which is the right pointer or the end of our best solution, plus 1, if ands of 0 actually does not equal to float infinity. Otherwise, we just want to return an empty string. So that is how you solve it. Let me just make sure I didn't make any syntax errors because this is a long problem. Okay, it looks fine. Let me submit this and we are good to go. Answer accepted. All right, so last thing that we want to do here is actually talk about the time and space complexity. So let's do that. So the time complexity here, let's think about it. So obviously we need to find all of the counts of t counts, right? So that is going to take big O of t time because we have to go through and basically find the counts of that. Now what we're going to do is we also need to parse through the entirety of s here. And we're going to do this in one pass, which means that essentially this is going to be big O of s, where s is the length of our string s here. So our total time complexity is going to be big O of t plus big O of s, because as you can see, we have to parse through the entirety of s here, and in the worst case, we also have to chop our solution, which could potentially take big O of s time. So that is the time complexity, and the space complexity is actually going to be the exact same thing. And let's think about why. So t counts, obviously, if t has all unique characters, then it's going to take big O of t space to store them in that dictionary. In the worst case, our window counts is actually going to end up storing all of the characters in the substring, right? It's going to be it wouldn't actually be a substring. It'd literally just be s, and in the worst case, s is going to have all unique characters. So what we're going to do there is it's going to take big O of s space to basically store all of those. So that is your time and space complexity here, big O of t plus big O of s, and that is going to be the same for the time and the space. So this is your best solution. It's going to be a linear one. It's only going to require one pass through your input here, and this is probably what your interviewer is looking for. So that's how you solve this problem. Hopefully you enjoyed this video, and hopefully it wasn't too long. If you made it to the end, congratulations, you now know how to solve this problem. It's actually quite easy, and once you've seen it once, I think it's really easy to memorize the solution. It's very intuitive, easy to explain. It is a hard question, but I guess once you've seen the solution, it becomes more of a medium. Anyway, I'm gonna stop rambling because I bet this video is already 25 minutes long or even longer. So thank you so much for watching. If you enjoyed the video, please leave a like and a comment. It really helps me with the YouTube algorithm. If you want to see more content like this, please subscribe to the channel. I have a lot more videos coming out soon, so you definitely don't want to miss those. Subscribe and hit the notification bell. Otherwise, thank you so much for watching and have a great rest of your day. Goodbye.